Hello and welcome to Mr. Tompkins EdTech and a brand new series of videos aimed at helping you prepare for your GCSE mathematics exams. In this series I'll be giving a complete walkthrough of the GCSE mathematics practice papers to help you prepare for your exams this summer. Now there are not so many of these and you don't want to squander them, so make sure you try the paper yourself first before you look at these solutions. This particular paper is June 2020, paper 1, higher tier. Check the front cover of your paper to make sure it's the same one. If it's not, have a look through the playlist linked above, which includes all the GCSE maths video walkthroughs I've recorded so far. I'm busy recording all of the GCSE practice papers, so if the one you're looking for isn't there already, why not subscribe by clicking the big red button below and check back in a few days. Don't forget to click on the bell so that you'll get a notification when I upload the next paper. I'll put timestamps in the description below, so you can choose to watch the whole thing through, or you can click on the timestamp and jump to the particular question you need help with. If you have a question, check the comments below, as someone else might have already asked the same thing. If it's a new question, leave it in the comments and I will try and answer all of them as soon as I can. Don't forget to mention which question on the paper you're referring to and try and be as specific as possible. Finally, if this video helps you with your revision, please give it a thumbs up. It will really help me out, and why not share the link with your friends, because they might need a helping hand too. Okay, let's get into it. Welcome along to another past paper walkthrough. Today we're going to be having a look at the June 2020 series. Now these are labelled a bit weird. It's actually got 19th of May 2020 written on the front cover. It's part of the June 2020 series, but it didn't actually go out in June 2020 because of the coronavirus, so it's now been released on the EDEXCEL website and it's listed as the November 2020 series, but it's still got like the May-June date stamped on the front of it. Okay, so hopefully that's cleared up the confusion. So it should say 19th of May 2020 on your front cover. It's part of the June series, but it was released in November. Yeah, let's get started. Question 1. The first 5 terms of an arithmetic sequence are 1, 4, 7, 10, 13. Write down an expression in terms of n for the nth term of the sequence. Okay, so an arithmetic sequence or progression is another word for a linear sequence. And it means that your terms are going up in equal increments each time. So if you have a look at the distance between here and here, you can see I'm adding 3 onto 1 to get 4. I'm adding 3 on, I'm adding 3 on, I'm adding 3 on. So it has what we call a common difference. Okay. Now, as it's going up in threes, it is going to be like the sequence 3n, which goes up in threes. It's 3, 6, 9, 12 and 15, but you'll notice that my numbers 1, 4, 7, 10, 13 are going up in threes, but they are actually 2 less than the 3n, aren't they? So this one is going to be 3n minus 2. So the nth term of this sequence is 3n minus 2. So it's going up in threes, but it's 2 less than the 3 times table. Okay, 3n minus 2. Question 2. Show that 2 1/3 times 3 3/4 is 8 3/4. Okay, let's do that. So if I'm going to multiply numbers together, mixed numbers like this, it's much easier to rewrite them first as improper or top-heavy fractions. We can do that by multiplying these two numbers together. So we times the whole number part with the denominator, and then we add on the numerator part. Okay, and that will tell me the numerator of my new number. So 2 times 3 is 6, plus the 1 is 7. So 2 2/3 is the same thing as 7/3. Okay, now I can do the same thing with the other number. I'm going to multiply the 3 and the 4 together. So 3 times 4 is 12. And then I'm going to add on the 3. So that's going to give me 15 over 4. Okay, so I've got 7/3 times 15 over 4. Now you've got a choice here. You can either just multiply top with the top and the bottom with the bottom first and then look to simplify, but actually it can be quicker and easier if you look to simplify first. So before I'm going to multiply, I'm just going to see if I've got any numbers in the numerators that I can cancel with the denominators. Now this 3 down here, look, I can cancel that 3 into the 15. 3 goes into the 15 5 times, so that cancels down like that. Okay, so rather than multiplying 7 by 15, now I just have to multiply 7 by 5, which is a lot easier. And that's going to give me 35 over 1 times 4 is 4. Okay, so just cancelling first means you end up having to multiply smaller numbers, and then you don't have to do that simplification step where you then, have to cancel down afterwards. Final step is to rewrite this as a mixed number. 4's into 35. Now you just do this like a division. 4's into 35. Well, 4's into 3 don't go. 4's into 35 go how many times? 8 4's are 32, aren't they? So it goes in 8 times, and the remainder is, difference between 32 and 35 is 3. So that's 8 remainder 3. So then that is going to be 8, because the number it goes in is your whole number part of your mixed number, and then the remainder part is going to be the numerator of your new fraction. And then finally the denominator stays the same, so I was dividing by 4 and I'm still dividing by 4. So that is 8 3/4 as required, so we proved it. Question 3, the diagram shows 4 graphs. Each of the equations in the table is an equation of one of the graphs. Complete the table. Okay, so I'm just going to have a look at these graphs one at a time and see if I can work out what its graph type is, and then match it to the equation down there. Okay, so graph A to start with. Now I've got this distinctive 2-part curve. It's got a break in the middle, and it kind of hugs the axis like that. That is the reciprocal curve, isn't it? It's going to be the form 1 over x, or a variant of it. So that's going to be this one down here, y equals 1 over x. Okay, graph B, now that looks to me like a cubic curve, because it's kind of an S shape, isn't it? Okay, so cubic curves either start high and end low, or start low and end high. This way round, where they start high and end low from left to right, is a negative one. So I'm expecting this one to be negative x cubed somewhere. Oh, and I've got one here. I've got a minus x cubed and a positive x cubed. It's going to be the negative one. Okay, x cubed is the other way around. It kind of looks like that way up. Okay, but we've got it inverted here. We've got it the other way around, so it's the negative one. Oh, look, here's the next one. So if I look at C, that is what I was expecting for a positive cubic curve. So that one's going to be C. And then finally, I've got this curve, which is what we call a parabola. That one is a cubic, is a quadratic curve, isn't it? So that one is going to be D there. Okay, that was nice and easy. Done. Question 4. The diagram shows 4 triangles. Yes, it does. 2 of these triangles are congruent. Write down the letters of these 2 triangles. Okay, well, we've got 4 rules, haven't we, for congruency? Side, 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 angle, side, angle, side, angle, and RHS, which stands for right angle, hypotenuse, side. Okay, so we're looking for those things within the diagram. Okay, if you have a look at triangle A, I've got 2 angles and an included side in that one. Okay, so that could be angle, side, angle, the third one there. Now the second one, I've got 2 sides. I've got an angle, but it's not the included angle, so that's not anything. I'm just going to cross that one out. That one is not going to be very helpful at all. Okay, now the third one, again, I've got 2 sides and an angle, but again, the angle is not the included angle, so it's not side, angle, side, because with side, angle, side, you have to have the 2 sides and the angle in between, and that angle is not. So again, that one we can't use test of congruency for. And then finally, I've got 80, 45, and 10. Now in first inspection, you might think, well, I've got 2 angles and a not included side. So again, I can't really use ASA. But actually, if you think about it, in a right angle, well, in a triangle, all the sides or all the angles add up to 180 degrees, don't they? So if I know that one's 80 and that one's 45, then the third angle, this angle here, is going to be 180 minus the other 2 then, isn't it? So if I add 45 and 80 together and take it away from 180, that's going to be 180 take away 125, which is 55. So actually that's a 55-degree angle in there. Okay, so now I do have two angles and an included side. Those two angles are 55 and 45, and the side in between is 10, which matches my other one, doesn't it? So these two one match. Okay, so the two sides that match, or the two triangles that match, are A is congruent to D. Question 5. Sean pays £10 for 24 chocolate bars. He sells all 24 chocolate bars for 50p each. Work out Sean's percentage profit. Okay. Now I like to do percentage questions using this triangle. Final, original, multiplier. So the method really involves just working out what I've been given out of those three things, which is the final, which is the original, which is the multiplier. Put it into the formula and work out our answer. So Sean pays £10 for 24 chocolate bars, and he sells 24 chocolate bars for 50p each. So what's that then? 24 times 50p. That comes out to be £12, doesn't it? Okay. So he buys them for 10 and he sells them for 12. So the original price was 10, and the final price was 12. And we want to work out the percentage the percentage profit, which is my M, my multiplier here. Okay. So next thing we need to stick our thumb on it. Put our thumb on the one we want to find, which in this case is the M. It's the multiplier. So I'm going to cover that one up, and then the triangle is going to tell me what to do with the other two. So multiplier is going to be equal to the final divided by the original. Okay. So subbing that in then. Final is 12, original is 10, 12 divided by 10 is 1.2 or 1.20, which is 120%. Now remember, we want to work out percentage profit. So when you're working these things out, you always start with 100%, don't you? We started with 100% of the cost of the chocolate bars, and now they've raised to 120%. So the percentage profit is the difference between 100 and 120%. So basically it's that there, isn't it? It's that 20%. So it's 20% more than 100%, so it's 20% profit. Question 6. ADC is a triangle. AED and ABC are straight lines. EB is parallel to DC. Angle EDB is 148 degrees and angle ADC is 63 degrees. Work out the size of angle EAB. You must give a reason for each stage of your working. Okay. Right, I'm just reading through. I just want to check that everything in the text is in the diagram, because it isn't always. So ADC is a triangle. ADC, yeah, that's there. Okay. AED and ABC are straight lines. So AED and ABC are straight lines. Yeah, that's all fine. What else have we got? Angle EBC is 148 degrees. There it is over there. Angle ADC is 63 degrees. That's over there, so that's on the diagram. Now we want to find the size of angle EAB. EAB, this angle up here at the top of the triangle. Okay. Now, so we already know one of the angles in the triangle, got this one. So if we can find this one over here, then we can, well, find the area of the angle at the top then, can't I, using the angles in a triangle? So we can say that angle ACD, this angle down here, is co-interior to this one, can't we? Because we've got a pair of parallel lines and a line crossing them, then these two angles here are the kind of the interior angles of a pair of parallel lines. So they add up to 180 degrees, don't they? So I can say that angle ACD is equal to 180 minus angle EBC. And the reason for that is they are interior angles of a pair of parallel lines, which is 180 minus 148. And 180 minus 148 is going to be, what's that, 32 degrees. Okay, so that one down there is 32 degrees. Now we know the angle at C, we can use the angles in a triangle sum to 180 degrees, can't we? So we can say that angle DAC plus angle ADC plus angle ACD, all of those add up to 180 degrees, don't they? And the reason for that is angles in a triangle sum to 180 degrees. Okay, so each time I'm doing a thing, I'm just writing down what the rule is. Okay, because remember, I have to give a reason for each step. Okay, so DAC, that's what I'm trying to find. So that means that angle DAC, then rearranging that, then is going to be 180 minus those other two, then isn't it? It's going to be 63 plus 32 taken away from 180. So 63 and 32 adds up to 95. 95 away from 180 is 85 degrees. And, well, they're the same angle, aren't they? And so therefore, angle EAB, which is the same thing as angle DAC, is going to also be equal to 85 degrees, isn't it? Okay. Question 7. The table shows information about the heights in centimeters of a group of Year 9 girls. This stem and leaf diagram shows information about the heights in centimeters of a group of 15 Year 9 boys. There it is. Compare the distributions and heights of the girls with the distribution and heights of the boys. Okay, so this is the girls' data here, isn't it? I'm just going to make this table a little bit bigger, and I'm going to add the boys' data on. Okay. So make this boys. Okay, so what are the boys' least height and greatest height and median? Well, the least height is going to be this one here, isn't it? It's the first leaf on my stem and leaf diagram. So the scale tells me that a 15 and 8 reads as 158. So that is a 15 and 8, so that must be 158 centimeters. Okay, now the greatest height is going to be the last leaf on my stem and leaf diagram. It's going to be that one up there. So that one is going to be 182 centimeters. Okay, and then the median is going to be, where's the median? So I've got 15. So the median is going to be the 15 plus 1 over 2th value, isn't it? So that's the median. So the 15 plus 1 over 2. We've got 15 values. Add 1 gives me 16. Divided by 2 is 8. So I need to count through my stem leaf diagram and find the 8th term, or 8th leaf. 1, 2, 3, 4, 5, 6, 7, 8. It's that one there, isn't it? Okay, it doesn't matter which end you count from. I could count back from the top. Should lead me to the same point. So the median for the boys is 168 centimeters. Okay, right, so what else do we need to do? I need to compare the distributions. Okay, so I'm going to compare the medians, and I'm going to compare the, well, I've got least height and greatest height, so I should be able to find range for both of these, shouldn't I? So the range for the girls then is going to be 170 take away 150. The greatest take away the least, which gives them a range of 20. And the boys is going to be 182 take away 158, which is, what's that? That's 24 centimeters, isn't it? Okay, so now I've got all the data I need to compare them. First off, I can compare like the central tendency or average. I can say on average, the boys were taller, and I can say, well, let me just put like what the range, so 168 centimeters versus 165. And I can also say something about the dispersion or the range, but there was more variation in their heights. Range 24 versus 20 centimeters. Okay, so I've compared their average, their median, and I've compared the range. So that's two good comparisons there. Right, done. Question 8. The diagram shows a prism placed on a horizontal floor. The prism has a height of 3 meters. The volume of the prism is 18 cubic meters. The pressure on the floor due to the prism is 75 newtons per square meter. Work out the force exerted by the prism on the floor. Okay. Well, we know that force is part of this pressure formula over here. Pressure equals force divided by area. So rearranging that, I know that force then is going to be equal to pressure multiplied by area then, isn't it? Okay. Now I know the pressure is given in the question. So the pressure there, look, is 75. Do I know the area? Well, I've got the volume of the prism, and I know a formula for the volume of a prism. So the volume of a prism is equal to cross-sectional area multiplied by its height, isn't it? Okay. Now here I've been given the volume. I've been given the volume is 18, so I know that bit. I know the height. I've been given that as well. The height is 3, so I know that bit. So I can rearrange that to find the cross-sectional area, and then that will be the area I need in my force calculation over there. So let's do that first. Rearranging this one, so area then is going to be equal to, just change sides on this. So this height on this side, if I divide both sides by height, then I'm going to get area equals volume divided by height then, aren't I? Okay. In this case, the volume is 18, the height is 3, so that gives me an area of 18 divided by 3, which is 6 meters squared. Okay. So now I know what the area is. The area then is 6. I could sub that in over here now, can't I, in the force calculation. So pressure was from the question, it was 75. The area I've just found is 6. So 6 lots of 75. 75 to 75 is 150, and 3 of those is what, 450? So that's 450. What is the unit? Force is going to be, well, pressure is in newtons per square meter. I've just multiplied by square meters, so that's going to give me newtons then, isn't it? Newtons, 450 newtons. Question 9, write these numbers in order of size. Start with the smallest number. When I first looked at these numbers, they all look like they were in standard form, but they're not, are they? Because the decimal points are all in the wrong place. I think what I'm going to do, I'm just going to rewrite them all in standard form. Okay, that's going to be the easiest way to compare them, I think. So 6.72 times 10 to the 5, that is already in standard form. Now this one, 67.2, that's the same thing as 6.72 times, now I've taken 10 out of it, divided it by 10, so I need to increase this power of 10 by 1, so it's going to be 10 to the minus 3. The other way of doing this is just writing them all as decimals if you want. You can do that as well. But I'm quite good with standard form, so that's the way I'm going to do it. 6.72, dividing the number by 100 or 10 to the 2. So I need to increase this by a power of 2, so it's going to be 10 to the 6. This one, decimal point is going to go there between the 6 and the 7. So it's moved 1, 2, 3, 4 places to the right. That's 10 to the minus 4 then. Okay, so now all my numbers are in standard form. I should be able to easily compare them. Okay, all I need to now look at is the main part of it is going to be the power, isn't it? The smallest power on the left, largest power on the right. The smallest one is 10 to the minus 4. So that's the one on the right is going to be my first one. So 0.0000672. I'm going to write them in their original form. Next smallest, I got minus 4. Then I've got minus 3 next. So that's going to be my next one. So that's the 67.2 times 10 to the minus 4. I'm just giving them back in the original form rather than my worked out one. Next biggest is going to be my power 5 over here. That's 6.72 times 10 to the 5. And then finally my 10 to the 6 one, which is 672 times 10 to the 4, that one on the end. Right, so that's all of them, isn't it? Question 10. Given that A over B is 2/5 and B over C is 3/4, find the ratio A to B to C. Okay, so we've got some equations, haven't we, in A and B, and what we need to do is turn that into a ratio. Now this often confuses people a little bit because the values end up being kind of the opposite way around as the formula would be. So here, if I rearrange this by cross multiplying it like that, okay, I'd get 5a equals 2b. So then the ratio of a to b is actually, the numbers are going to switch around. It's going to be 2 to 5. Okay, now before you go, what's that about then? Think about, let a be the number 2, then 5a would be 10. Okay, so then what would b have to be? So it's also 10. It would have to be 5, wouldn't it? Because 2 times 5 is 10. So actually the numbers kind of switch around when you switch from a formula into a ratio. Okay, a bit confusing, but it is what it is. Right, now this next one I'm going to do the same thing. I'm just going to cross multiply. I'm going to put the c up there. I'm going to put the 4 up there. So that's going to give me 4b is equal to 3c. And in other words, the ratio of b to c is going to be in the ratio of 3 to 4. Just switching the numbers around again. Okay, so now I've got my ratio for a to b and my ratio for b to c. I'm going to have to kind of stitch them together. And the way that I'm going to have to do that is I'm going to have to make the b number the same, because the b is in both. Okay, now at the moment b is not the same. I've got a 5 and a 3. So what I'm going to do is I'm going to scale up these ratios so that that's the same number for both. Okay, it's kind of like a common denominator of 5 and 3, isn't it? That's what we're doing. So what can I do with the ratio of 2 to 5 to make a common denominator of 5 and 3? Well, the common denominator of 5 and 3 is 15. Okay, so I'm going to have to make this one 15. I'm going to have to make this one 15. So 5 to 15, that is multiplying by 3. Doing the same this side, I'm going to get 2 lots of 3 is 6. So 2 to 5 is the same as the ratio of 6 to 15. And 3 moving up to 15, that's times in by 5, times in this one by 5. 4 times 5 is 20. Okay, so my ratio of a to b is now 6 to 15. My ratio of b to c is now 15 to 20. Now, because these numbers are now the same, 15 and 15, I can kind of stitch them both together into one ratio, a to b to c. I can use my 6 to 15 here and my 15 to 20 here. So that makes it 6 to 15 to 20. Okay? Right. Now, can I simplify that down? Don't think so. 15 has factors 1, 3, 5, and 15, none of which is common to 6 and 20. So that's it. That's in its simplest form. 6 to 15 to 20. Question 11a. Find the value of the fourth root of 81 at times 10 to the 8. Okay? Right. Okay, now first off, if you remember, finding the fourth root of something, that is the same thing as raising something to the power of a quarter. It's a fractional index, isn't it? Okay, so power quarter is the same thing as the fourth root. Now, powers like this over brackets are distributive over multiplication, so that is the same thing. I can distribute that quarter, power quarter, to each of those two things separately. That's the same thing as 81 to the power of a quarter times 10 to the 8 raised to the power of a quarter. Right, now 81 to a quarter, what's the fourth root of 81? I happen to know that one because it's quite a common one. If you think about 3 times 3 is 9, times 3 is 27, times 3 is 81. So 81 to the power of 1 quarter is 3. And then times 10 to the 8 times a quarter. When you've got an index of an index like this, so you've got an index and you raise it to an index, you just multiply those together, don't you? So what's 8 times a quarter? Well, it's the same thing as 8 divided by 4. That is 2, isn't it? So that's 10 to the power of 2. 3 times 10 to the 2. 10 to the 2 is 100. 3 times 100 is 300. So that's my answer. 300. Right, find the value of 64 to the power of minus a half. Now, I treat these as two separate steps. They've got the negative index part, and you've got like the fractional part here. If the numerator was something other than 1, I'd have a third part as well, but as it's 1, I've just got the two steps. Right, so let's deal with the negative number first. A negative index is the same thing as 1 over the positive version of that index. So that's the same thing as 1 over 64 to the power of a positive a half. So I've dealt with the minus sign now. Now I need to deal with the fractional part, the 2 there, of the denominator of 2. So that's the same thing as before. That means the square root of then, isn't it? So that's the same thing as 1 over the root of 64. What's the square root of 64? It is 8, isn't it? So that is 1/8. Okay. Finally, part C, write 3 to the power n over 9 to the power of n minus 1 as a power of 3. Well, first off, I know that 9 is 3 squared, isn't it? So that means I can replace this 9 in here with 3 squared. Okay? So I've got 3 to the power n divided by 3 squared to the power of n minus 1. Okay? Now, 3 squared to the n minus 1, I've got an index of an index here again, isn't it? So I would multiply those two indices together to find a single index. So then that is equal to 3 to the n divided by 3 to the 2n minus 2, because 2 lots of n minus 1 is 2n minus 2. Okay? And then when I divide numbers with the same base, I'm subtracting the indices. Okay, so that is the same thing as 3 to the power of n minus 2n minus 2. And what's that then? So removing the brackets, I'm going to get n minus 2n, which is 3 to the minus n, and then negative minus 2, or take away minus 2, that is plus 2, isn't it? So I've got minus n plus 2, which I might just spin round actually and write the other way around, 2 minus n. So as a single power, it's going to be 3 to the power of 2 minus n. Okay? Quite a tricky one, that one. Cool though. Question 12. The table gives information about the weekly wages of 80 people. And I've got 200 to 220, 250, which is 5, 250 to 300 is 10, and so on. And it says underneath, complete the cumulative frequency table. Okay, so the first category, 200 to 250, is the same as the one at the top, isn't it? So this one is here. It's just going to be the same as that. It's going to be 5. Now the next category, 200 to 300, that involves these two categories here. So it's going to be the 5 and the 10 together, which is 15. Next category, 200 to 350, that includes this one as well. It's going to have to add on another 20. So that comes to 35. And we keep doing the same thing. We're just going to add the next one on to the previous one to find the next cumulative frequency. So the next cumulative frequency is going to add the 20, which is 55. Then add the 15, which is 70. And then add the 10, which is 80. Now it's a good idea at this point just to check your answer here, because they often tell you how many that you're expecting in the question. So you just need to double check your cumulative frequency matches up with the total you're expecting. Okay, so that's part A done. Part B, we need to then plot those values on the graph. Now when you're plotting the cumulative frequency curve, you are plotting upper class bound against cumulative frequency, not lower class or middle. Okay, so my first point, actually I can put one bonus point on. I can put 0 at the lower class bound of the first point. So I'm going to put like a cross at 0 to 100. Okay, because I've got nothing below 200. So then my next point is going to be at 250 as a height of 5. Okay, then after that I've got 15, a height of 15 at 300. So there. Then at 350, I'm going to be plotting 35. So there. And then 400 is going to be 55. There. And 70 at 450. And finally 80 at 500. Now it should give you a kind of familiar S-shaped curve. I'm going to actually join these points up in that curve. Okay, just as close as you can through each of the points. Okay, it should flatten out at the top. Okay, so that's my cumulative frequency curve. Finally, Julian says 60% of the group of people have a weekly wage of £360 or less. Is Joanne correct? You must show your answer. So 60% of the group of people. What is 60%? 60% of 80. 60% of 80. Okay, what's that then? 100% of 80 is 80. 50% is going to be half that, it's going to be 40, and 10% is going to be 100% divided by 10, isn't it? It's going to be 8. So then 60% is going to be that one and that one added together, isn't it? 50 and 10 make 60, so 40 and 8 make 48. Okay, so 48 is what I'm looking up then on my cumulative frequency. So if I get my ruler out and then draw across from 48, change direction, draw down. Now I make that, is that 360? It looks about 360, doesn't it? I think he is correct. So that is 360 down there, isn't it? Okay. Is Juin correct? Yes, because, well, you know, it says show how you got your answer, C graph. Okay, because I've shown it graphically, I don't have to explain it all. So I looked across at 48 and I got 360, and that was the evidence I needed. So 6% of the group have a weekly wage of 360 or less. Then these people down here, look, this is the 60%, and they have a wage of 360 or less. So yeah, it's true. Question 13. Liquid A and liquid B are mixed to make liquid C. Liquid A has a density of 70 kilograms per cubic meter, and liquid A has a mass of 1,400 kilograms. Liquid B has a density of 280 kilograms per cubic meter, and liquid B has a volume of 30 cubic meters. Work out the density of liquid C. Okay, so to work out density, we've got like the formula, haven't we? We've got density equals mass over volume, isn't it? Volume. Okay, so in order to work out the density of liquid C, we're going to have to know the mass of liquid C, and we're going to have to know the volume of liquid C. Okay, so we can find the mass of liquid C by taking the mass of liquid A and the mass of liquid B and adding it together, and we can find the volume of liquid C by adding the volume of liquid A and the volume of liquid B together. Now, unfortunately, we don't have all those things, do we? We've got the mass for liquid A, we don't have the volume. We got the volume of liquid B, we don't have the mass. But we do have the density of both liquid A and B. So we're going to have to use this density formula rearranged first to find the missing thing, then add them together and then work out the new density. Okay, so let's have a look at liquid A first. So for liquid A, what have we got? We know the mass, we know the density, we want the volume. So the volume is equal to, rearrange that formula, I'm going to get mass over density, aren't I? It's just a matter of swapping these two things around then, isn't it? So density goes down, volume comes up, so I get volume equals mass over density. Okay, so subbing that in, then I've got 1400 divided by 70. Okay, so I'm just going to scratch that 0 on the end. So I've got 140 divided by 7. Well, 10 sevens are 70, so that's going to be 20 then, isn't it? So that's going to have a volume of 20 cubic meters, because I've got kilograms per cubic meter and I've divided by, and I've got kilograms, so that's going to give me cubic meters. Okay, so that's 20 cubic meters for the volume of liquid A. Now for liquid B, I need to work out its mass this time, don't I? So if density equals mass over volume, then mass, rearranging that, is going to be density multiplied by volume, isn't it? Rearranging that one. Okay, so the density is 280 and the volume is 30. So multiplying those together, 28 times 3, so 28, 48, 56, 66, 76, 84. So 8400 then, 8,400 kilograms. Looks a lot bigger than the other one, but it's a lot denser. So maybe that's why. Just double checking that's right. It looks a bit big, but yeah, it's probably about right. Yeah, that's all fine. Okay, so then liquid C. Now I know everything about liquid A and B, I can now work out liquid C. Okay, so for liquid C, its mass is going to be the two masses added together then, isn't it? It's going to be the 1400, which is the mass of liquid A, and my mass of liquid B that I added together there. So it's going to be 1400 plus 8400, which is 9800. And then its volume is going to be the two volumes added together. So I worked out the volume of liquid A to be 20. I was told the volume of liquid B was 30. So adding those together, so my volume then is going to be the sum of those two. It's going to be my 20 plus 30, which is 50. So then density is going to be mass over volume, which is my 9800 divided by 50. So scratch that 0 off the end. 5's into 980. When I divide by 5, I kind of double it and divide by 10. That's what I tend to do. So 980 doubled is 181960, and then divide by 10 is 196. 196 what? Density is going to be kilograms per cubic meter, isn't it? Kg per m cubed. 196. Question 14. Sally plays 2 games against Martin. In each game, Sally could win, draw, or lose. In each game they play, the probability that Sally will win against Martin is 0.3. The probability that Sally will draw against Martin is 0.1. Work out the probability that Sally will win exactly one of the 2 games against Martin. Okay? Right, so if we were going to draw this as a probability tree, which is a bit long, I'm going to say we're only really interested if she wins. We're not really interested if she draws or if she loses. So what I'm going to do is I'm going to merge the lose and draw together to simplify down my tree diagram. Okay, so let's just work out what that is then. So the probability that she wins is 0.3. Now the probability she draws is 0.1, so that means the probability she loses is going to be the rest, isn't it? So I'm just going to say the probability of not win. Okay, if the probability of win is 0.3, then the probability of not win is going to be 0.7. Now that's going to include the 0.1 of a draw, plus it's going to be the 0.6 then I suppose of the loss. Okay, but like I say, I'm not really interested if she draws or loses. I'm just interested if she wins. I just want to know the probability that she wins exactly one of the 2 games. Okay, so I'm not going to draw win, draw, loss, and because that's going to give me like a horrendous. I don't want to do that. That's too much. Okay, so I'm just going to get rid of the draw option. I'm going to say she either wins or she does not win. Okay, so the probability that she wins then is 0.3, and the probability she does not win is 0.7. And that's going to be the same on the second go as well, isn't it? So I've got win and not win, which is 0.3 and 0.7. This is independent, so all the branches are going to be kind of equal to each other, aren't they? They're going to be the same. Okay, so then the winning exactly 1 is going to be the probability of win, not win. Probability of win, not win, plus the probability of not win, win, isn't it? Probability of not win, win. Okay, so the probability of win, not win is 0.3 times 0.7, which is 0.21. Okay, and then the probability of not win, win is, well, it's going to be the same, isn't it? It's going to be 0.7 times 0.3, which is also going to be 0.21. So then the probability of exactly 1 win is going to be the probability of win, not win, plus the probability of not win, win, which is 0.21, plus 0.21, which is 0.42. Okay? Job done. Question 15. The straight line L1 is equation y equals 3x minus 4. The straight line L2 is perpendicular to L1 and passes through the point 9,5. Find the equation of the line L2. Okay, so we've got equation 1, equation for L1, which is y equals 3x plus 4. Now, equations are normally written in the form y equals mx plus c, where m is the gradient. So here, look, the gradient of this first line is going to be 3. Let's just make that a little bit clearer. Don't know why it came out to be a minus sign. I tried to write a plus. Right, so that's gradient of the first line is 3. So I'm going to say in L1, then M1, the gradient is equal to 3. Then the gradient, I'm going to call it M1, equals 3. And then in L2, gradient M2 then is perpendicular, which means it's going to be the negative reciprocal of M1, isn't it? So it's going to be minus 1 over M1, which is going to be minus 1/3. Okay? So the gradient of M2 is going to be minus 1/3. So then we know equation then of L2 of the form y equals minus 1/3 of x plus c. And we know that it passes through the 0.95. So we can sub those values in, like x is 9, y is 5, into our equation. And then the only thing we won't know is c, which we could then find. So subbing in y is 5. 5 is equal to minus 1/3 of x, which is 9, plus c. So minus 1/3 of 9, that's 1/3 of 9 is 3, so that would be minus 3. So 5 equals negative 3 plus c. Adding 3 to both sides, I'm going to get 8 is equal to c then, aren't I? Okay, so therefore, equation of L2 is y equals minus 1/3 of x plus 8. Okay, we did it. Question 16. Shirley wants to find an estimate of the number of bees in her hive. On Monday, she catches 90 of the bees. She puts a mark on each bee and returns it to her hive. On Tuesday, she catches 120 of her bees. She finds that 20 of these bees have been marked. Work out an estimate of the total number of bees in her hive. Okay. Right, so when she catches the bees on Monday and she puts a mark on 90 of them, then that 90 is going to be a fraction of the total number of bees. Okay, and on Tuesday, when she catches 120 bees, she's found that 20 of them is marked, which is 20 over 120, or 1 in 6. So she finds that 1/6 of the bees marked. Okay, so what you can say there, that my 1/6 of the total number of bees, so let's say there are X number of bees altogether, and a 6 of them then is going to be 90 then. I can equate those. And then rearranging, multiplying both sides by 6 then, X, my estimate of X is going to be 90 lots of 6s then, isn't it? Or what's 6 90s? That's 54 with a 0 on the end, 540. So I reckon there must be about 540 bees in the hive. Now, in part B, it says Shirley assumes that none of the marks have rubbed off between Monday and Tuesday. If her assumption is wrong, explain what effect this would have on your answer to part A. Right, so if some of the marks had rubbed off, then that would mean that there were more bees that out of that sample of 120 that she selected, more of them would have had marks on. You wouldn't be able to see some of them, because some of them would have rubbed off. So we got the 6th by doing 20 over 120. Now if this number then would be more because some of them had rubbed off, so the number of 20 would be more than 20. So then this fraction as a whole would be have a bigger numerator, same denominator, so the fraction would have been a bigger fraction. So that means that this divisor would have been smaller, wouldn't it? Because rather than a 1/6, it would be like a 1/5 or a quarter, a smaller, a larger fraction but a smaller denominator, wouldn't it? The denominator would get smaller there, so that when I multiplied through by this denominator on this side, that amount would be smaller, and so the number of b's would be smaller. So what does that mean in terms of the question? It means that in actual fact there would have been a fewer than 540 b's. So that means we've overestimated the number of bees in the hive. 540 would be an overestimation. Okay, I think that kind of makes sense. Yeah? Right. Let's move on. Question 17. Make f the subject of the formula. Now you need to take care with this one because actually f appears in two places. It's down here and up here. So it's one of the hardest sorts of rearrangements that you need to do. And it's going to involve some extra steps. Right, so the first thing I'm going to do is I'm going to cross multiply the denominator. So I'm going to multiply through by this bit down here. So I'm going to multiply both sides by f minus 4. So if I times f minus 4 on both sides, f minus 4 times that, it's going to cancel with that one, and it's going to leave me with d lots of f minus 4 equals 3 lots of 1 minus f. Okay, now multiplying out the brackets, that's going to give me df minus 4d is equal to 3 minus 3f. Okay, so I've got f's on both sides. We're going to have to get all the f's on one side. So I'm going to add 3f to this side and to this side. Okay, so it gets rid of it there. And that's going to give me df plus 3f minus 4d is equal to 3. And then I'm going to do the opposite of minus 4d. I'm going to add 4d to both sides. Okay, so then that cancels with that. And it leaves me with df plus 3f equals 3 plus 4d. Okay, now notice I've got an f in both of these expressions. I've got an f there and an f there. That means I can factorize out the f. And that's going to give me d plus 3 in the bracket equals 3 plus 4d. And then finally, I can divide both sides by d plus 3. And so then that will cancel with that. And it'll leave me with f on the left-hand side. And I'm going to get 3 plus 4d over d plus 3. So the trick of these ones, when you've got f appearing in two different places, you want to try and collect them all on one side and either, collect like terms or factorize out the f out of the various terms if you've got other things multiplied by it. Okay, job done. Question 18. X is proportional to the root of y where y is greater than 0. Y is increased by 44%. Work out the percentage increase in x. Okay, well, let's form an equation in y and x first. So x is proportional to the root of y then. So x then is going to be some multiple of root y. Okay, now if I increase y by 44%, I've got 100% to start with. So if I add on 44%, that's 144%, which as a multiplier is 1.44. Okay, so what I'd be doing is I'd be taking my value of y and I'd be increasing it by a factor of 1.44. Okay, so if I was to do that, then that would be the same thing as, well, what's the square root of 1.44? That's equal to k lots of root y root lots of 1.44, and the root of 1.44 is like 144. Root of 144 is 12, so the root of 1.44 is going to be 1.2. So that's going to be k root y times by 1.2. Okay, so what's going to happen then is the value of x is going to increase. Well, it's going to be multiplied through by 1.2, which is the same thing as 120%. So 1.2 is the same thing as 120%. So if you've got 120% of what you started with, then that is a 20% increase. We did one of these earlier, didn't we? Percentage increase. It was a profit last time, but it works the same way. So yeah, 20% increase. Question 19. F and G are functions such that f of x equals 12 over root x and g of x equals 3 lots of 2x plus 1. Right, find g of 5. Okay, well g of 5 is just taking my g of x and replacing x with 5. So that's going to be 3 lots of 2 lots of 5 plus 1. Okay, so 2 lots of 5 is 10, plus 1 is 11, times 3 is 33. So g of 5 is 33. G f of 9, that is like taking my 9 and subbing it into f, and then taking that and subbing it into g. Okay, so f of 9 is 12 over root 9, which is 12 over 3, which is 4. So then taking that answer and feeding it into g, so g of 4 is going to be, so g of 4 is 3 lots of 2 lots of 4 plus 1. 2 lots of 4 is 8 plus 1 is 9 times 3, 27. Okay, so fg of 9 then is going to be 27. And finally, g to the minus 1 of 6. Now g to the minus 1 is the inverse function of g. You can find the inverse function by rearranging the function first. So I'm going to say let y equal 3 lots of 2x plus 1. I'm just replacing g of x with y. I'm going to rearrange it and make x a subject first. So I'm going to do that first by dividing both sides by 3. So I'm going to get y over 3 equals 2x plus 1. I'm going to take 1 away from both sides. So that's going to be y over 3 minus 1 is equal to 2x. Running out of space here, let's just put a line here. And then dividing both sides by 2. So half of y over 3 minus 1 is equal to x. Can I tidy that up? Yeah, so I'm just going to do the half times y over 3. And that's going to be y over 6 minus a half then. That's going to be equal to my x. So then my inverse function, g to the minus 1 of x, is going to be that function. So I'm just going to replace back the y's with x's. It's going to be x over 6 minus a half. Okay, so then what is g to the minus 1 of 6? G to the minus 1 of 6, that's going to be 6 over 6 minus a half. 6 divided by 6 is 1. Take away a half is a half. It's just going to be a half. Okay, job done. Question 20. Show that root 180 minus 2 root 5 divided by 5 root 5 minus 5 can be written in the form a plus root 5 over b, where a and b are integers. Now this looks like fun. Okay, what can we do here then? Right, first off, I've got this bit on the top here. I reckon I can make that a little bit neater. Now 180. Now I reckon that's going to have some square factors. Well, I can think of 9. 9 goes into 18, but there's actually a bigger one. 36 is a factor of 180, isn't it? Because it's 5 lots of 30. It's 5 lots of 36. So I could rewrite root 180 as the root of 36 times 5 minus 2 root 5 over 5 root 5 minus 5. Okay, so then splitting that up into root 36 times root 5. Root 36 is 6, so that's the same thing as 6 root 5 minus 2 root 5. Right, rather than writing 5 root 5 minus 5 on the bottom, do you notice that they've both got 5 in them? So I can factorize that out as a common factor, can't I? I can say that that is 5 open bracket root 5 minus 1. Okay? And then on the top part there, I've got 6 root 5 minus 2 root 5. Now, if I've got 6 lots of something minus 2 lots of that same something, I can just subtract one from the other. So 6 minus 2 is 4, so that's 4 root 5 on the top. And that's over 5 lots of root 5 minus 1. Now, annoyingly, I have got a surd as part of my denominator, which mathematicians consider to be somewhat ugly. So we're going to get rid of that, and the way we're going to get rid of it is we're going to multiply top and bottom by kind of the conjugate of this bit in here. So I've got root 5 minus 1. So what we do is we take the sign of that and we flip it around. So I'm going to multiply top and bottom by root 5 plus 1. All right, now that should become apparent why we do it in a second, because we're kind of doing FOIL on these two brackets. So I've got 4 root 5 on the top, which I'm going to be multiplying through by root 5 plus 1. Okay, and on the bottom, I've got 5 lots of root 5 minus 1 times root 5 plus 1. It's a bit like the difference of two squares. So you're going to end up with the two middle terms cancelling each other out. So you're going to get the first term, first two terms multiplied together. I'm going to get root 5 times root 5, which is 5. And then I'm going to get the last two terms multiplied together, minus 1 times positive 1, which is minus 1. Okay, so it basically results into doing that, which is why I multiply through by like the positive version of that one over there. Okay, so let's tidy this up a little bit. I'm going to kind of create a second column here because I'm running out of space. So 4 root 5 times root 5 first on the top. I'm going to multiply both things by 4 root 5. So 4 root 5 times root 5, well, root 5 times root 5 is 5. 4 times 5 is 20. So that's going to give me 20. And then 4 root 5 times 1 is just 4 root 5. So I'm going to end up with 20 plus 4 root 5 on the top. On the bottom, I've got 5 multiplied by 5 minus 1. 5 minus 1 is 4. 4 times 5 is 20. So I get that. I get 20 plus 4 root 5 over 20. So I'm getting quite close to the form that I need to get it into. I think what I'm just going to do is I'm going to divide that 20 into both parts separately. Okay, so 20 divided by 20 is 1, and plus I'm going to get 4 root 5 over 20. Now this cancels down, doesn't it? Because 4 goes into 25 times. So that's going to give me 1 plus root 5 over 5 then. Okay, that's my answer. 1 plus root 5 over 5. Question 21. DEF is a triangle. P is the midpoint of FD. Q is the midpoint of DE. F to D equals A. F to E equals B. Use the vector method to prove that PQ is parallel to FE. Okay, I'm just going to go through and read that carefully again and just reflect on the diagram a bit. So DEF is a triangle. Well, I know that. DEF is a triangle, so no great shakes there. P is the midpoint of FD. P is the midpoint of FD. That means that this line here and this line here are the same length. Okay, and then what else do we know? That we know that Q is the midpoint of DE. So Q is the midpoint of DE. Again, I know that that is the same length as that then, don't I? Okay, now we know that F to D equals A. F to D equals A. So this vector here, from here all the way up to here, that is the vector A. And F to E is B. So F to E, that is the vector B. Okay. Use the vector method to prove that PQ is parallel to FE. PQ, which is not marked, is parallel to FE, which is marked. Okay, let's just draw on that line PQ. See, we want to find its parallel. Let's just draw it in. Okay, so we want to show that these two lines are parallel. Now with vectors, parallel basically means one is a multiple of the other, because vectors have magnitude and direction. So two lines that are parallel should be going in the same direction, which means one needs to be a multiple of the other. Okay, so that's what we're going to prove. We're going to prove that P to Q or F to E is some multiple of P to Q, basically. Right, so how are we going to do that? Well, our first problem is Q is a point not on one of our vectors A or B. Okay, so we can't get to point Q currently using the vectors that we know. Okay, so how can we get to Q? Well, we could get to Q down this way. Okay, we could get to it that way. Now, I don't know that vector line from there to there, but I do know that this entire line here, D to E, is the same thing as going via the other way. I could go from D to E, and that would be the same thing as going from D to F and then F to E like that. So I'm going to find that first. I'm going to find DE in terms of the vectors that I know. Then I'm going to find DQ, and once I got DQ, I should be able to then start navigating around my shape a little bit easier. Okay? Sounds long, but we'll get there. We'll get there. Right, so what is vector D to E? Vector D to E, now that is the same thing as going from D to F and then going from F to E. Yes? Yes. Now D to F we know is the opposite direction of vector A, so that's going to be minus A, and F to E we know is B. Okay, so D to E is B minus A basically, isn't it? Okay, now D to Q is going to be, well, remember we said that Q is the midpoint of DE, so that means that D to Q is going to be half the distance from D to E then, isn't it? We just found D to E is B minus A, so that's going to be half of B minus A. Okay, so now we've got a vector from D to Q. Are we cooking on gas yet? So now I think we can find P to Q then, can't we? So what's P to Q? Now P to Q, I could go from P to D, and then I can go from D to Q. Okay, so P to Q is P to D plus D to Q. Now P to D, again, P is the midpoint of FD, so P to D is going to be half of F to D, isn't it? Okay, and F to D is the vector A, so that's going to be half of the vector A, and D to Q we found was a half of the vector B minus A. Okay, so P to Q then is half A plus half B minus A, so removing the brackets there, that's going to be half A plus half of vector B minus half of vector A. And you should see that then those two cancel, and that just leaves you with half B. Okay, so now I found P to Q is half of B. I already knew that F to E was B, so now I can see that P to Q is some sort of scalar multiple of the other one. So I can say, but F to E is vector B. So therefore P to Q is half of F to E then, isn't it? Okay, so one is a scalar of the other, and therefore that's enough to say they are parallel. Therefore PQ is parallel, can't spell parallel, parallel to, can't spell to FE. Okay, so PQ is parallel to FE. Well, that was lots of vector fun. I like that. That's good. Question 22. The diagram shows two shaded shapes, A and B. Shape A is formed by removing a sector of circle with radius 3x minus 1 from a sector of a circle with radius 5x minus 1. Shape B is a circle of diameter 2 minus 2x centimeters. The area of shape A is equal to the area of shape B. Find the value of x. You must show all your working. Okay. Right, so we know that this shaded bit in here is equal to the shaded bit in here. So these two areas are equal to each other. So what we're going to do now, let's work out the area of the circle first, because that's easy. Okay, area of B. Area B, that's going to be, well, B is a circle, isn't it? So it has area of pi r squared. Okay, and here the radius of this circle, what is the radius? Well, I know the diameter is 2 minus 2x. So if we divided that by 2, I'm going to get 1 minus x then is the radius then, isn't it? Because the radius is half the diameter. So that's pi lots of 1 minus x all squared. Okay? It's not very nice, but anyway, we'll just leave it like that for now. So area of B is pi lots of 1 minus x all squared. Now let's have a think about area A. Area A is two sectors, isn't it? Subtracted from each other. So a sector has a formula, like it's the fraction of the circle, isn't it? So you take that angle at the center and write that as a fraction over 360. So this sector is 45/360ths of the larger circle. Okay, so but what we've got is we've got one sector, the big triangle, the sectory bit, with this second smaller sector cut out of it, isn't it? Okay, so it's going to be 4/360ths of, now I could do 45/360ths of the big sector. I think mathematically what would be easier though if we say, I'm going to kind of find like the donut first, if you see what I mean. So like this is a big shape like this, isn't it, with like a big circle with a little circle cut out, and then I'm going to slice it up into this sort of shape, and that's the kind of area that I've got. But rather than doing 45/360ths first, I'm going to take the area of the big circle, I'm going to subtract the area of the little circle, and then I'm going to find 45/360ths of it. Okay, just simplifies it down a little bit. Okay, so it's going to be 45/360ths of the area of the big circle. So the radius of the big circle is this. So it's actually those two things added together, isn't it? So the radius of the big one is 3x minus 1 plus 2x. So it's going to be pi r squared, where r is 3x minus 1 plus 2x. 3x minus 1 plus 2x squared. And then minus pi r squared, but this time r is just 3x minus 1. Okay, it seems to have kind of budged a bit off the edge of my page. Let me just kind of budge that back over again so you can see it all. Okay, so now what? So notice I've got a pi in here twice. So I'm going to factorize that pi out. So it's going to be 45 pi over 360 lots of. So I've got 3x minus 1 plus 2x, which is 5x minus 1 all squared, minus, so I actually have a square there, 3x minus 1 all squared. Okay, and apparently these two things are equal, so I should be able to then equate these two things. So I should be able to equate this with this. I was hoping it's going to cancel down, but it doesn't look like it just yet. I'm going to have to multiply lots of brackets out. I was hoping to avoid such complexities. Anyway, let's see. So 45 over 360 lots of 5x minus 1 all squared minus 3x minus 1 all squared is equal to pi lots of 1 minus x all squared. Okay, well, I'm going to cancel out this pi. At least I'm going to get rid of that. That makes me feel slightly happier, but I still got a lot of work to do here. This is not very nice. Well, I'm going to get rid of the fraction straight away. I'm just going to multiply both sides by 360, I think. Just going to move that 360 away, so at least then I don't have a fraction. So that's going to be 45 lots of all of this, and then that's going to be 360 lots of my thing there. Am I going to multiply these out? I suppose I'm just going to have to multiply them out, aren't I? So 5x minus 1 all squared. I'm going to use the identity a plus b all squared equals a squared plus 2ab plus b squared, to just speed this up a little bit. If you don't know this identity, learn it, or just use FOIL. Goes the same, just goes a bit slower. So 5x, I'm going to square the first term. That's going to be 25x squared. Then two lots of the two terms multiplied together. So that's going to be minus 10x, and then I'm going to get minus 1 times minus 1, which is plus 1. And then in the second bracket, oh, and there's a minus sign as well, so maybe I'll keep these separate for now. Minus 3x squared is 9x squared minus 3x times 1 times 2, which is 6x plus 1, and then that is equal to 1 minus 2x plus x squared over there. So then that is equal to 45 lots of, let's collect like terms now. I've got 25x squared minus 9x squared. That is 16x squared. Minus 10 minus 6x. So that's minus 4x. And then 1 minus 1. Well, that at least disappears. So that leaves me with that. And then that is equal to 360 lots of, well, just what I had before. I'm just going to turn it around there. X squared minus 2x plus 1. Okay. Blimey. Multiply out the brackets now. So 45 lots of 16. Seems to be a lot of work. There must be an easy way of doing this, surely. I think I'll divide both sides by 45 just to cancel this down a little bit. So rather than having 45 and 360, if I divide both sides by 45, that would have been much more sensible to do much earlier. So dividing that side by 45, dividing 360 by 45, 45s into 360 go 8 times. So that would give me 8 there instead, wouldn't I? Dividing both sides by 45. So I've got 16x squared minus 4x equals 8 lots of x squared minus 2x plus 1. So multiplying out that bracket as well, I'm going to get 8x squared minus 16x plus 8, and that's equal to 16x squared minus 4x. Okay, bring everything to one side. I'm going to get ax squared plus 12x minus 8 is equal to 0. And dividing through by 4 then is going to give me 2x squared plus 3x minus 2 equals 0. Right, I'm just going to, well, what have I got now? Can I factorize that? I probably can. Let's see if I'm just going to work over here because I ran out of space over there. So I'm going to have, can I factorize that into two brackets? I've got 2x squared at the front, so let's make that 2x and x. I've got minus 2 at the back, so how can I make plus 3 in the middle? If I've got like plus 2 there, then I'm going to get 4x. Yeah, that works, doesn't it? So 2x minus 1, x plus 2 should multiply out to be 2x squared plus 3x minus 2, which gives me two solutions. X equals a half or x equals minus 2. Now, x equals minus 2 does not work in this scenario. I cannot have a radius which is negative, which it would be in that case. Okay, so that can't be the answer. It must be that x is equal to a half. Can't be negative. So find the value of x. It's a half. Whew. Well, that was a job. Blimey. But we got there in the end. Looks like a bit of my working over here fell off the end of the page, so I've just kind of budged it over a bit if you were wondering what had fallen off there. I think it was this bit over here, wasn't it, that you couldn't see. Okay, so there you go. Job done. Question 23. There are 4 types of card in a game. Each card has either a black circle or a white circle or a black triangle or a white triangle. Now we're told that the number of cards with a black shape to the number of cards with a white shape is in a ratio of 3 to 5, and the number of cards with a circle compared to the number of cards with a triangle is in a ratio of 2 to 7. Express the total number of cards with a black shape as a fraction of the total number of cards with a triangle. Ew, that's hideous. What are we going to do here then? So if the number of cards with a black shape to the number of cards with a white shape is 3 to 5, that means that 3 over 3 plus 5, or 3/8 of the shape, are black. Okay, so 3/8 of the total cards are black shapes. Okay, so that's black shapes. I suppose black shapes equals 3/8 of total. Yeah, so black shapes is 3/8 of the total number of shapes. Express the total number of cards with a black shape as a fraction of the total number of cards with a triangle. So the total number of cards with a triangles, that is going to be, well, there are 7 out of 2 plus 7, or 7/9 of total. Okay, so the number of triangles is 7/9 of the total, and the number of black shapes is 3/8 of the total. So express the total number of cards with a black shape as a fraction of the total number of cards with a triangle. So in other words, what we're doing is we're making one super fraction with our 3/8, the number of black shapes, which is 3/8, over, expressed as a fraction, over 7/9. In other words, we're doing fraction division, aren't we? Well, that's what that means. So that's the same thing as 3/8 divided by 7/9, then, isn't it? Okay, which keep, change, flip means that we keep that one, we change that one, we flip that one over, don't we? So it's actually that 3/8 times 9/7. Okay, so what can we do there? Can we simplify? No. Let's just multiply them out then. 3 9s, 27. 8 7s, 56. So it's 2756. You can find more exam question compilations over here. For more past paper walkthroughs, click down here. If you want to visit my Amazon shop with my recommendations for calculators, revision guides and other maths related stuff, click down here. Good luck in your revision and in your exams, and see you again next time.